5.1, perpendicular and angle bisectors. Okay, so example 1, how can you find points that are equidistant from the end point of AB? What do you notice about these points and their relationship with AB? Okay, so what we're going to do is we are going to create a circle around A. So I've got my circle around A. I want to make sure that my circle is centered on A. Then I'm going to duplicate it and put a circle around B. Again, I'm going to center it. Okay, so I've created 2 circles that are kind of representing the arcs that we would be creating with a compass. And I'm going to go ahead and create a line that goes through the intersection of those arcs where the circles are intersecting. Okay, so I've got my line that's going through the 2 intersections. And any point that would fall on this line would be equidistant from the 2 points. Okay, so then our try it. Draw a pair of fixed points and find points that are equidistant from the 2 fixed points. Draw a line through the set of equidistant points. Repeat this process for several pairs of fixed points. What conjecture can you make about the points that are the same distance from the given pair of points? All right, so we first want to create 2 points. And I'm going to create a circle around them to represent the intersecting arcs. Then I will duplicate it. So that I keep the size, because I want these to be the same distance from that center point. And I will center it. And then I want to draw a line that goes through the 2 intersections. So I've created my line of intersection. Okay, so let's say that I wanted to test this and make sure that everything's working. I could create smaller circles. Actually, I think I'll do bigger circles. Okay, we'll do a bigger circle. And we'll see that we're going to have the same point of intersection. And then Duplicate that one. Okay, so my two circles, I have two separate size circles. They both have, so my blue circles have the same diameter as my other blue circle. My red circle has the same diameter as my other red circle. And my line is going through both of those. Okay, so the points that we created are creating a perpendicular bisector. Okay, so let's look at a couple of theorems. We've got our perpendicular bisector theorem that tells us that if a point is on a perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. And then the converse of that is the opposite. So if a point is equidistant from the endpoints of the segment, then it is on the perpendicular bisector. All right, so we've got example number 2. We need to prove the perpendicular bisector theorem. We are given line L is the perpendicular bisector of XY, and we need to prove that PX is congruent to PY. So we'll create our statement and our reason proof. Okay, first we know that PQ is congruent to PQ through the reflexive property. All right, number 2, we know that angle XQP is congruent to angle YQP. And we know that because right angles are congruent. And we know that these are right angles because they told us that line L is a perpendicular bisector with XY, which means it's creating right angles. 3, we know that triangle XQP is congruent to triangle YQP. We can prove that because we know that, we've already done this reflexive, we know that this section is congruent to this section because they told us that line L is a perpendicular bisector of XY, which means it's cutting it evenly in half and it's creating two congruent segments. So we now have a side, an angle, and a side to prove the triangles. So side, angle, side. We also have side, 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 so we could use side, side, side to prove it. Okay, 4. We can finally prove that PX is equal to PY. And we can prove that through corresponding parts of congruent triangles are congruent. All right, our try it, we need to prove the converse of the perpendicular bisector theorem. Okay, so we've got our statement and our reason. So our first statement, we know that PX is equal to PY. and that was given. Our second reason is that angle PXY is congruent to angle PYX. And that is because we have an isosceles triangle, and we can use the isosceles triangle theorem. All right, our third reason is because XQ is congruent to QY. And that is by definition of midpoint, because they told us, or because we know that we have a midpoint. All right, 4. We know that we can now prove that triangle PQX, or PXQ, by side angle side now. Okay, number 5. We are able to prove that triangle PXQ is congruent to triangle PYQ through corresponding parts of congruent triangles are congruent. We know that angle PQX would be congruent to angle PQY, and that each of those would equal 90 degrees. And that would be through congruent, supplement, right angle theorem. And then finally, we would be able to prove that PQ is perpendicular to XY by definition of perpendicular lines. All right, example 3, use of perpendicular bisector. All right, Mr. Lee wants to park his ice cream truck on Main Street so that he is equidistant from the entrance of the amusement park and the zoo. Where should Mr. Lee park? How can he determine where to park? All right, so he wants to be equidistant between the entrance of the amusement park and the zoo. So the first thing I'm going to do is I'm going to create points at those entrances. And I am going to connect them with a line. Try to get that a little bit better centered. All right, so I want to find my intersection. So I'm going to create a circle, 2 circles, so I can find where they intersect. So I've got my first circle. I'm going to center it on my first point. And then I want to duplicate it. And then center the new one. Okay, I'm going to create a line that goes through the two intersections. And goes all the way out to the street. Try to center this line a little better. Label my points. Okay, so we would want to set up our cart right off of the street here at T. Okay, so Mr. Lee should park at point T. Or try it. The entrances are 40 feet apart. Mr. Lee decides to move his cart off the street to the area between Main Street and the entrances to the amusement park and the zoo. How can you find where Mr. Lee should park if he must be 30 feet from both entrances? Okay, so they're telling us that the entrances are 40 feet apart. That means this would be 20 feet and this would be 20 feet. We're going to use the Pythagorean theorem to find how far away he should be parking. Okay, so again, our Pythagorean theorem, we would have a squared plus b squared equals c squared. Our c squared is our hypotenuse. Our hypotenuse is, if I've got my triangle, let me go ahead and sketch out a triangle. So let me do it this way. Okay, so I've got my triangle here. This is our 20 feet from the midpoint to the park entrance. We know that the cart must be 30 feet from both entrances, so this would be 30 feet. We don't know this missing side. Our hypotenuse side is that 30 feet. And then we'll solve for our missing variable here. Okay, I have x squared equals 500. If I have a square, the opposite of a square is a square root, so I'm going to take the square root of both sides. So I'm going to be left with x equals the square root of 500, which will get me 22.36. Okay, so our missing side here is 22.36 feet. All right, next apply the perpendicular bisector theorem. What is the value of AD? We know that these two sections are congruent, so I would set them equal to each other. So 6x minus 10 equals 3x plus 2. Move a variable over. Add my constant over. and then divide by 3. All right, so we found our x, but we're looking for AD. So now I'm going to take that x I just found and plug it in for AD, which AD we know is 3x, which x we found is 4, plus 2. So we would get 14 for the measurement for AD. All right, or try it. We want to find the value of WY, which means we need to find N. We know that these two segments are congruent, so we're going to set them equal to each other. Move a variable over. Add our 2, and then divide by 3. We need to plug in our value for WY, which WY is 2N, and we found to be 3 plus 7. So we would get 13 for the value of WY. B, we want to find the value of OL. So we're trying to find OL right here. I know that the value of NL, the entire length here, would be the same as this 14, but I'm looking for just half of that. So I would take 14, divide by 2 to get me 7 as the measurement for OL. All right, example 5. An airport baggage inspector needs to stand equidistant from 2 conveyor belts. How can the inspector determine where he should stand? Okay, so we want to create perpendicular bisector with each of the conveyor belts. So I would be creating a perpendicular bisector. Try that again. All right, so I went ahead and I drew out the perpendicular bisectors for the conveyor belt, just because it's a little bit difficult to do on this tablet. So I created segments that are perpendicular to the conveyor belt, and then I added an intersecting line that went straight through the middle to show the intersections. Okay, so we've got our airport baggage inspector, and we now have the line that shows where he can stand to be evenly spaced in between the 2 conveyor belts. All right, or try it. Consider the 2 triangles that result from drawing a segment from the point on the angle bisector where the inspector stands to each conveyor belt, forming a right angle with that conveyor belt. How are the triangles related? Okay, so they're asking us about these 2 triangles here, and they want to know how they are related. Okay, so we know that those 2 triangles are going to be congruent because of angle, angle, side. We know that they have two angles that are congruent and a side that... Okay, so we know we have 90-degree angles here. I know that I am bisecting this angle, so I'm creating two congruent segments, and this side is congruent because it is the same thing, and we're using the reflexive property. So they would be congruent by angle, angle, side. All right, our angle bisector theorem. If a point on the bisector of an angle, then it is equidistant from the two sides of the angle. And then the converse of that, if a point is equidistant from two sides of an angle, then it is on the angle bisector. So let's apply that. So KL, we want to find the value of KL. Well, I know that these two segments are congruent to each other because of that angle bisector theorem. So I know KL would be congruent and equal to LM. So then I would take 2x plus 3 and set it equal to 4x minus 11. And now I'll solve for x. So I'll move a variable over. Add my 11. And then divide by 2. Okay, so I found x, but I want to solve for KL. So KL is 2x. Well, x we found is 7 plus 3. So 14 plus 3. So I would end up getting 17 for KL. Okay, our triad. They told me that HI is 7, IJ is 7, and that the measure of HGI is 25 degrees. And we want to find the measure of IGJ. So we're trying to find this angle. Okay, if HGI is 25 degrees, and both of these measures here, HI and JI, are congruent and equal to each other, then that means my measure for angle IGJ has to also be 25 degrees. Okay, next we're going to look at B. So the measure of HGJ, the entire measure, is 57 degrees. IGJ is 28.5, so just half of it is 28.5. And HI is 12.2. We want to find the measure of IJ. Okay, so if my entire angle measure is 57, if one segment is 28.5, that means my other segment has to be 28.5. So my angles are congruent to each other. If the angles opposite the side are congruent, then that means the sides are going to be congruent. So this IJ would also be 12.2.